everyone, and thank you for joining my presentation on building MLOps for autonomous mortgage AI. I want to start by asking you to imagine this scenario. Now, you have found your dream home, you made an offer, and now you're waiting for mortgage approval. In a traditional world, a mortgage application goes through 47 manual steps and it takes anywhere from 30 to 60 days. And all the while, workflows, either manual or digital, goes between people and within different departments. But imagine if that entire process could happen in 3 days and also with better accuracy and compliance than the old manual system. And just to introduce myself, I am Naganarendar and I have spent the last several years building exactly these kind of systems in the mortgage industry. Today, I want to walk you all through how MLOps principles can transform one of the most paper heavy and regulation intensive industry into something that can actually work for customers in the 21st century. And just to provide a sense of what's at stake, the mortgage industry processes about $2 trillion in loans and just in the US alone, and this is an annual figure. When you apply modern MLOps to that scale, with all the regulatory complexity and legacy system challenges, you get some of the, fascinating technical problems to solve. More importantly, you get the opportunity to make real difference in people's lives because, you know, to be honest, buying a home shouldn't feel like navigating a bureaucratic, maze from the 1980s. And just to give you a short, explanation about myself. Now, to give you some context on where I'm coming from, I've been working at the intersection of AI and financial services. And what I find most interesting is how MLOps principles had to evolve, especially when we applied them to heavily regulated industries like mortgage lending. Now, that $8 million savings I mentioned in my PowerPoint isn't just a number on a slide. It actually represents thousands of families who got approved faster application approvals with fewer errors and less frustration. The generative AI chatbot we built now handles about 60% of all customer service inquiries, which means agents can now focus on the really complex cases that need genuine expertise. Now, why this domain is special? And here's what it makes mortgage MLOps more fascinating from a technical perspective. Traditional MLOps assume you can move fast and break things. In mortgage lending, breaking things means someone might not get a home that they've always dreamed about. Or worse, you might even violate fair lending practices and face multi-million dollars in fines. So we have to get creative on how to apply these principles safely. I'd like to start by going over the industry challenges on adopting MLOps. Let me start by giving you a sense of how complex traditional mortgage processing really is. Like I mentioned previously, there are 47 distinct steps from initial application to closing. And that's for a very straightforward purchase loan. There are other forms of loan types that can be even more complex and have more distinct steps. And I also wanted to quickly walk you through a real world scenario. Now, someone applies for a mortgage through an online portal on Friday evening. That application is going to sit in a queue until Monday morning when a human processor will pick it up. Then they need to verify the employment of the application owner, which means calling HR departments that might not respond until Tuesday. They have to order an appraisal, which gets scheduling for the following week. Meanwhile, the credit report needs manual review, bank statements get analyzed line by line, and then there are dozens of regulatory compliance checks. Now, each step involves different people, often different systems that don't talk to each other, which is typical in any industry. And there are countless opportunities for applications to get stuck in queues and also to fall through the stacks. Here lies the technical opportunity from an MLOps perspective. You are dealing with incredibly diverse data types, structured data from credit bureaus or unstructured data from documents like tax returns and bank statements and real-time feeds from property valuation services. Now, all of this has to integrate with mainframe systems that were built when, probably in the 1970s or 80s. But when you apply modern MLOps principles correctly to this problem, you can reduce the 30 to 60 day processing timelines to just 3 to 5 days, while also improving accuracy and regulatory compliance. That is the transformation that we are going to talk and explore here today. Now, I want to discuss the unique technical challenges and regulatory hurdles, in building AI-enabled MLOps for mortgage industry. Scaling is the first reality check. When I talk about scaling in mortgage, I'm talking about processing 100,000 plus applications daily. And this is especially during peak period volumes like spring home buying season. But it is not just about high volume, it is high volume of incredibly complex, high stakes decisions. Each application might involve dozens of ML models working together, like fraud detection, income verification, property valuation, risk assessment, and even compliance checking. The second hurdle is the regulatory complexity. Now, here's something that makes mortgage MLOps fundamentally different from almost any other ML domain. Sustainability is not just to have a nice feature, it is a legally required feature. If we deny someone a loan, we have to be able to provide specific, understandable reasons that regulators can audit. That means every model decision needs to be traceable back through the entire data pipeline with complete lineage. There was a situation where I remember one regulatory auditor where an examiner asked about a specific loan decision from 18 months ago. In traditional systems, that would mean days of detective work going through log files and database records. With proper MLOps architecture, I could pull up the complete decision tree in seconds. Which models were involved, what data were used, which business rules were fired, and even the exact version that were active at that moment when the rule engine ran. Now, there's also the legacy integration reality that we all know about, which is probably the most challenging aspect of the mortgage MLOps. We have a critical loan data living in mainframe systems from the 1980s. There is no REST APIs, no JSON, no microservices, just batch files and data formats that literally predate the World Wide Web. Now you end up building entire AI systems whose primary job is to just translate between the modern MLOps pipelines and these legacy, systems. It is like building universal translators for computer systems that speak completely different languages. Traditional MLOps principles had to evolve significantly when we applied them to mortgage processing. Now, let me walk you through how each core area had to be reimagined. The first aspect is data governance. Data governance in mortgage AI goes way beyond typical ML governance. Every piece of data that influences a loan decision must be tracked with complete lineage, not just for debugging, but also for legal compliance. Now, we need to know what data was used, when it was collected, how it was processed, who had to access it, and how all these contributed to the final decisions. Now, we developed something what I call compliance first feature engineering, where every feature pipeline automatically includes bias detection, PII anonymization, and audit trail generation. The feature engineering code itself generates documentation that compliance officers can actually understand and use in regulatory submissions. Now, the second aspect is model deployment practices and its evolution. The model deployment looks completely different too. We cannot just optimize for accuracy, we have to simultaneously optimize for fairness, explainability, and regulatory compliance. The training pipelines include automated fairness validation across different demographic groups, bias detection, and explainability report generation. We developed something we call a regulatory aware cross validation architecture, where our validation sets are specifically constructed to test model performance across different demographic groups, geographic regions, and market conditions to ensure we are not unknowingly creating discriminatory outcomes. The other aspect is deployment becomes complex, especially because mortgage applications can take 30 to 60 days to process. If we deploy a problematic model, we might not discover the issues until weeks later when loan starts performing poorly in the real world. That's why we developed extended shadow mode testing where new models run in parallel with production models for our complete loan life cycles, even before we considered switching the traffic to these new models. We are essentially running dual processing pipelines to validate behavior over long time frames and also for end-to-end applications. I want to discuss next on the key components and challenges in building AI-driven mortgage data pipelines. I want to start with complexities in data ingestion. Now, let me paint a picture of what data injection looks like in Mortgage AI. You are dealing with PDFs that might be scanned at weird angles. Bank statement with hundreds of different formats depending on the bank. Now, pay stubs may come from different companies that all format them very differently. And this complexity that I'm talking about is just on the document processing side. Then you have real time data feeds from credit bureaus, property valuation services, and employment verification systems, each with their own API quirks, rate limits, and occasional outages. During PC periods, we might be making about 50,000 to 100,000 API calls per hour to external systems, and each service has different reliability characteristics and failure modes. Now, these are not even our biggest challenges yet. Our document processing pipeline is probably one of the most complex parts of the entire system. We use an ensemble OCR model. Think of it as a combination of different OCR models because no single OCR model can handle all different document types effectively. Then we have named entity recognition models that are specifically trained for financial documents. They understand the difference between gross income and net income, and they can also identify debt obligations versus assets, recognize different types of employment documentations as well. But this is where it really gets interesting from an MLOps perspective. We have to maintain separate, discrete model versions for different document vintages. Pay stubs from 2020 may look different from one in 2024, and the models need to be able to handle both types of documents because people submit historical documents as part of their applications to, especially to prove their credit worthiness. Then every single piece of data flowing through these pipelines have to be handled with extreme care. Now, again, we implemented what we call privacy by design pipelines architecture, where PII gets automatically identified and masked. Sensitive data is encrypted both at rest and in transit, and every access is logged for audit purposes. The feature store becomes very critical here, especially because it allows us to pre-compute these features while maintaining strict privacy boundaries. The credit scoring model never sees raw bank statements at all. It only gets carefully engineered financial behavior features because it preserves privacy and also it enables providing accurate decisions. Now, there is also the storage reality that we all have to face. We maintain multiple storage tiers optimized for different use cases. Hot storage for real-time decision making with less than 50 millisecond retrieval requirements. Warm storage for model training and experimentation. And the last one is the cold storage for long-term regulatory retention. The challenge here is to maintain consistency across all these tiers and also ensure that we are maintaining performance requirements. Training data for Mortgage AI presents some, like I said, unique and fascinating challenges. You need historical loan performance data to understand what makes a good loan. But you also need to account for changing market conditions, evolving regulations, and demographic fairness requirements because these tend to change, if not frequently, occasionally. The data itself tells stories about economic cycles, regulatory changes, and social evolution. Now, we generate synthetic data strategically for such edge cases and bias mitigation. Now, let's say, for example, we might not have enough historical data for a certain demographic group or in certain or specific geographic regions. So we have to use generative models to create realistic synthetic applications that help ensure our models perform fairly across all populations. Now, this is not just about filling data gaps. Think of it as proactively testing model behavior in scenarios in which you haven't seen how to handle them correctly. Also, rather than building one massive model that does everything end to end, you have to build specialized models for different aspects of the loan decision. Like, one model for income verification and one for fraud detection, one for property valuation, and one for compliance checking, etc., etc. And you have so many different workflows in an end-to-end, mortgage application processing. Each model is optimized for its specific task and they communicate through our event-driven architecture. This approach gives much better explainability because we can trace decisions back to specific models and its particular features. It also makes debugging and iterative improvements much more manageable than trying to tune one giant model and breaking things along the way. Now, our validation process also goes way beyond traditional ML validation. We run business KPI simulations before any model goes to production. We simulate how the model would have performed during historical market stress events, like the 2008 financial crash or during the early pandemic period of 2020. Now, we test fairness across protected demographics with statistical significance testing. One of our most important validation step is what we call a regulatory compliance simulation, where we run the model against historical data and verify that its decisions would not only have violated any fair lending practices, but also not create any discriminatory impact. Now, deployment in mortgage industries requires a much more conservative and sophisticated approach than any typical ML application. We've developed something called a three-phase deployment strategy that minimizes risk while also maintaining business continuity and regulatory compliance. Now, the first step is shadow mode. And shadow mode in this context isn't just running models in parallel. It's about running complete loan processing workflows in parallel. Newer models process real applications, but their will not affect customers. Human underwriters will be there to see both the production decision and the shadow model decision. And they provide detailed feedback on the quality and reasoning of shadow model recommendations. Now, this gives us incredibly rich validation data beyond any technical accuracy metrics. We can see where the model's decisions would have led to better business decision outcomes and also for faster processing times and improved customer satisfaction. The second aspect is canary release sophistication. Our canary releases are much more sophisticated than typical E&D tests. We don't randomly assign applications to different models. We carefully select applications based on risk profile, demographic characteristics, loan types, and geographic regions so that we can ensure we are testing across all the different relevant scenarios. We also monitor KPIs in real time because canary releases if loan approval rates are shifting outside expected statistical bounds, if processing times increase beyond thresholds, or if customer satisfaction scores drop. We have an automated system that can roll back these models within minutes to previous versions. Now, the third aspect is full deployment monitoring. Even after full deployment, we maintain comprehensive parallel monitoring systems. Each model decision is logged with complete context, and we track both technical metrics and long-term business outcomes. We can correlate model confidence scores with actual loan performance, but this will happen over months or years and later to continuously improve our systems and validate the decision-making quality. Now, CI/CD in mortgage industry is significantly more complex than typical software deployment because you're not just deploying code. You're also deploying decision-making systems that affect real people's financial lives, and they also need to comply with regulatory federal regulations. Our model registry is like a combination of Docker Hub and a compliance database. Each model version includes not just the trained weights and inference code, but they also contain comprehensive fairness testing results. They also contain regulatory compliance documents, performance benchmarks across different market conditions, and detailed explainable reports. Before any model can be promoted to production, it has to pass automated tests for technical performance, bias detection, regulatory compliance, and business impact simulation. We also maintain detailed metadata about which models are approved for which loan types and for geographic regions and also for market conditions. Now, when it comes to comprehensive testing, our test suites include standard model test unit like data processing logic and integration tests for model serving infrastructure. However, they also include mortgage specific tests that don't exist in other domains. We test model behavior during simulated market stress scenarios, validate fair lending compliance across demographic groups, and also verify integration with all the external services we depend on. Now, One of our most valuable tests is what we call the end-to-end simulation, loan simulation, where we run thousands of synthetic loan applications through the complete pipeline and also validate that all the models work together correctly and they also produce explainable decisions. And we also make sure that it meets regulatory requirements. Now, we also use external configuration management extensively because mortgage regulations change frequently and we need to adjust business rules without redeploying all the models. Our models will pull their decision thresholds, feature weights, and compliance rules and business logic from external configuration systems and rule engines at runtime. This capability became very crucial, especially during the pandemic, when lending criteria needed to change almost weekly in response to economic conditions and regulatory guidance. The next slide is about orchestration and workflow automation in mortgage MLOps. Now, mortgage workflow orchestration is incredibly complex because you're coordinating dozens of different systems, also external services, and human reviewers across multiple workflows. Now, this can take, like I said, typically weeks to complete or even months. Now, unlike typical ML pipelines that might run for minutes or hours, these workflows have to maintain a steady state and coordinate activities over month-long periods. Now, managing state, especially across long-running workflows, is very critical. You have to use event sourcing extensively so you can reconstruct the complete history of any loan application and at any point in time. This is not just useful for debugging. Now, it is also essential for regulatory audits where we might need to explain every decision made many months ago using data and models that we have updated since. Now, we also use event-driven architecture extensively to manage this complexity. When a credit score gets updated during the loan processing, now this event triggers cascading events that cause risk models to recalculate not just the pricing models to adjust interest rates, but also compliance systems to re-verify regulatory requirements. All automatically, all in parallel, and all with proper audit trails. Now, the beauty of this approach is that adding new models or changing business logic does not require modifying existing systems. Everything communicates thoroughly through well-defined events. Now, which makes these systems much more maintainable and adaptable. Now, we also integrate with dozens of external services like credit bureaus, property valuation services, employment verification system, title companies, insurance providers, etc., etc. Now, each API has different API patterns and they all have different rate limits. They all have different reliability characteristics and failure models. Now, we build a comprehensive service mesh that handles circuit breaking, retries, failovers, and back pressure management automatically. Now, during peak periods, we might hit rate limits, especially with these external services. So the orchestration system should automatically queue requests, manage these back pressures, and optimize the order of operations to ensure we don't lose the application state or violate service level agreements. Now, the final aspect here is intelligent automation triggers. Now, this is needed to maintain a sophisticated automated trigger for model retraining. Now, based on performance degradation, data drift detection, or significant changes in market conditions. Because these triggers also include business logic, we don't retrain models during the busiest processing periods or right before important regulatory reporting deadlines, especially when system stability is crucial during these periods. Legacy integration is probably the most challenging and underestimated aspect of mortgage MLOps, and integrating with legacy systems that are literally older than most people who are actually working on training or building these ML models. We have a very critical loan data in mainframe systems from the 1980s. Now, these systems process batch files once daily or depending upon the frequency of how frequency it is required. Now, these use data formats that vastly predate JSON format by decades and have zero modern API capabilities, but they contain decades of loan performance data that's essential for training accuracy risk models accurately. Now, we ended up building what we call legacy translation agents, especially specialized AI systems whose entire job is to speak to just mainframe systems. Now, they convert modern event streams into archaic formats that a mainframe will understand, and also translate back the modern data structures that is an output of our ML models back to mainframes. So they can both work with each other. Now, legacy systems often have data quality issues that human processors have over the years learned to work around over decades. Now, missing fields, inconsistent formatting, business logic that's embedded in user interface screens rather than databases, undocumented transformations that happened years ago. Now, our ML systems had to learn to handle all these different quirks automatically. Development of these sophisticated data quality pipelines can only detect and often automatically fix these issues is necessary. When they can't fix problems automatically, they route applications to human reviewers with very detailed explanation of what exactly is needed and where the attention is needed and why. On the same note, we cannot just turn off legacy systems overnight. They're running critical business operations that generate billions in revenue. So parallel processing validation, where both legacy system and new ML systems process the same application simultaneously, should be developed and put into practice. Now we can compare outcomes, build confidence gradually, and shift processing from legacy to ML as we process the systems work correctly. This approach not only gives us incredible insight into where the legacy systems were making suboptimal decisions, but it also helps us understand the business value of the ML transformation. Now, from an MLOps perspective, legacy integration requires building sophisticated data abstraction layers, building modern APIs that provide consistent interfaces regardless of whether data is coming from a cutting edge microservice or a 40-year-old mainframe system. Now, this abstraction allows the ML models to focus on making good decisions rather than dealing with all the complexity of data source integrations. Compliance isn't just in mortgage is not just going to be an optional factor or something that you can add later. It is going to be the foundational architecture that everything that you build is going to be on. Every model decision has to be explainable in terms that human underwriters, customers, and especially federal regulators can understand and validate. Now, one has to build build automated explanatory generation directly into every model in the pipeline. Now, when a model makes a decision, it automatically generates explanations that include which features were most important and how those features were calculated. Now, what data sources were used in those calculations, and also how the decision aligns with the regulatory requirements. Now, these explanations are not just going to be for internal debugging, like I previously mentioned. They are used in actual adverse action notices that get sent to loan applicants when applications are denied. Now, these explanations have to be accurate, understandable, and especially legally compliant. A continuous bias monitoring system should also be running across all demographic groups and protected characteristics. These models are trained to optimize for both accuracy and fairness, simultaneously using specialized loss functions and constraint optimization. If we detect bias emerging in certain model decisions, now we can trace it back to specific features, training data issues, and or model architecture problems and fix them systematically. Now, this is not only about being ethical, even though it is obviously important, it is also about avoiding a multi-million dollar regulatory fines, and also which is in turn required for maintaining our license to operate in this heavily regulated industries. Also, the next aspect, security in mortgage MLOps means protecting some of the most sensitive personal information that exists. It may be income, it may be the customer's income or their assets or their credit history or their employment details, so on and so forth. Now, the practice of end-to-end encryption, the zero trust networking, and principle of least privilege access controls throughout the entire system architecture needs to be used from day one. Now, every model interaction is logged for audit purposes, but the logs themselves are encrypted and also should be access controlled. We can prove to regulators that we tracked who accessed what data and when, but we can also demonstrate that sensitive information was never exposed inappropriately and shared only in situations where required and to the right stakeholders. We also automated as much compliance reporting as possible because manual compliance processes don't scale with volume of decisions these systems are going to make. Now, our systems generate regulatory reports automatically. They track fair lending metrics in real time or near real time and alert us immediately if any metrics drift outside acceptable ranges defined by our internal regulatory guidance. Next, I want to talk about how can we implement efficient strategies to meet the performance demands. Performance requirements in mortgage industry are driven by both customer expectations and business economics. Customers expect instant pre-qualification decisions when they're shopping for homes. But comprehensive underwriting needs to balance both speed and accuracy because the financial stakes and regulatory stakes are very high. Now, the use of model quantization and pruning helps reduce latency without sacrificing accuracy. However, implementing intelligent caching for frequently accessed features and common application patterns is very crucial. Using predictive prefetching, where we anticipate what data and features will be needed based on the current application characteristics. Now, during peak periods like the spring home buying season, which I mentioned previously, we might process 3 times the normal volumes. Our auto scaling policies monitor queue depth, processing time, resource utilization, and also external service response time to automatically spin up additional capacity to scale up or scale down as and when required. Now, we also optimize cost by using different infrastructure tiers strategically, like real-time decision models on high performance instances with guaranteed resources. All the while, batch processing models use spot instances and preemptible VM. We also use predictive scaling based on historical seasonal patterns to minimize infrastructure waste while also ensuring performance during demand spikes. Now, we monitor everything from multiple perspectives, anywhere from model latency percentiles, resource utilization across the entire stack, external service response times, queue depths, and most importantly, business KPIs like loan approval rates and customer satisfaction. Now, our dashboards show technical metrics alongside business impact metrics. So now we can understand the business consequences of any performance issues immediately. Mortgage AI systems can fail in ways that they don't show up immediately, like other traditional application monitoring. Model degradation due to very, very subtle market changes might not become apparent until weeks or sometimes even months later when loan performance data comes in. Now, a bias issue might only surface when you analyze approval patterns across demographic groups over time. Now, using statistical drift detection to monitor input data distribution, but you also need to monitor business outcome changes continuously. If loan approval rates are suddenly shifting, or if you see average processing times are increasing, or if you notice that your customer satisfaction or dissatisfaction rates are dropping, or if you see the agent overrides rates are spiking, then you need to investigate immediately, even though your technical metrics are all looking normal. Now, the incident response includes automated technical rollback capabilities, not just for infrastructure issues, but also involves human expertise loops for business anomalies. Now, when technical problems occur, we have automated systems that can restore service quickly. But when business metric anomalies occur, we have to immediately bring in domain experts because they are the ones who understand mortgage markets and regulations and also customer behavior. Now, every incident becomes a structured learning opportunity. You have to conduct thorough post-mortem that include both technical root cause analysis and also business impact assessments. Now, these learning will automatically feed back into your monitoring systems, alert thresholds, and also and should also eventually go into your deployment procedures and also helps in your model validation procedures. Finally, I want to talk about future directions and key takeaways from today's discussion. Now, LLMs are already transforming document processing in mortgage industry. Instead of training dozens of specialized models for each document type, now using LLMs that can understand and extract relevant information from any financial document with minimal additional training is the next step. This dramatically reduces the complexity of document processing pipelines. Now, federated learning is becoming an interesting concept in mortgage industry because it could enable collaboration between institutions while maintaining strict data privacy. Now, imagine you're training a better fraud detection model using insight from across the industry or even your competitor. Now, without any of these institutions sharing sensitive data or sensitive customer data. Now, let me leave you with couple of essential lessons from building MLOps systems, especially for mortgage industry that apply broad and not just mortgage industry, but to any broadly regulated industry. Now, the first one is regulatory compliance isn't a constraint that you should always work around. From the get-go, it should be an architectural requirement that you design into every component. Now, trying to add compliance later exponentially expensive, and it is sometimes an expensive and impossible tech debt to complete. Now, the second one is legacy system integration will always be more complex than you expect. So plan for it. You allocate significant budget, time, and resources. Now, you also build abstraction layers that can evolve as you gradually modernize your legacy systems into as you modernize your legacy systems. The third aspect is business outcome monitoring is just as important as technical monitoring. Your technical metrics can look perfect, but your business outcomes are quietly degrading in a ways that, like I said, will not be apparent until weeks or even months later. And also, change management and stakeholder buy-in are absolutely crucial. The most sophisticated ML system in the world will fail if the people who need to use it don't understand it or trust it or see the value in it. There has to be a mixture of both top down and bottom up approach. Now, when you're getting MLOps right in the mortgage industry, the transformation is going to be dramatic and measurable. Now, loan processing times will drop from weeks to days, accuracy will improve significantly, your operational cost will decrease substantially, and regulatory compliance becomes automated and bulletproof. And most importantly, the entire home buying process will become something customers actually enjoy rather than enduring for weeks or months. Now, the mortgage industry has been essentially unchanging for decades, but MLOps will give us the tools and techniques to transform it completely. The organizations that master this transformation, especially the first one to master them, will dominate the next era of financial services. The technology exists, the techniques are proven, and the business case is also compelling. Now it is just a matter of execution. Now, I also want to thank you all for your time today. I am excited to continue. I'm excited to continue to have these conversations and also help more organizations successfully apply MLOps principles and transform their industries successfully. Now, let's align, adapt, and accelerate for a breakthrough transformation. Thank you.